Hello good people, I'm going to demonstrate how to perform unit conversions. As cells are the basic unit of life, I thought they would be appropriate examples. The average length of a bacterial cell is about 1.75 micrometers. We need to convert that to centimeters. There are several methods that can be used to perform unit conversions, and I'm going to show you my favorite one. But before I do that, I want to get a sense of what the answer should be. Whenever we convert from a small unit to a bigger unit, the number itself will decrease. Conversely, if we go from a big unit to a small unit, the number itself will increase. In this case, we are going from micro to centi. Micro is smaller than centi, which means we are going from small to big, and therefore I expect my number to be less than 1.75. With that out of the way, let me perform the conversion. We're going to start by expressing the given value as a fraction. I know, you love it already. 1.75 micrometers expressed as a fraction would be 1.75 micrometers over 1. The next step is to multiply by a conversion factor. I do not know what it is going to be just yet, so I'm going to leave a blank fraction. And when everything is said and done, I'm hoping to end up with something in centimeters. I'm going to use the expected result to guide my conversion factor. I want to have centimeters above the line in the result. Therefore, centimeters should go above the line in the conversion factor. That means that the starting unit, micrometers, goes below the line. Next, I ask myself which unit is bigger, centimeter or micrometer. Well, it is centimeter, and I place a 1 next to the bigger unit. Now I ask myself how many micrometers to a single centimeter. Recall that this is a metric system, a base 10 system. I can already write the 1, I just need the number of zeros. The number of zeros will come from my unit scale. I'm going to use the values that each prefix represents. More specifically, I'm going to use the exponent in the scientific notation. Centi has a value of 1 times 10 to the power of negative 2. I'm interested in this negative 2. Micro has a value of 1 times 10 to the power of negative 6. I'm interested in this negative 6. What is the difference between negative 6 and negative 2? Well, it is 4. And that difference tells me how many zeros I will need in my conversion factor. In this case, 4 zeros. Now that I have my conversion factor in place, I'm simply going to multiply these two fractions. And that will give me 1.75 centimeters over 10,000. The micrometers above the line and the micrometers below the line will cancel. And finally, when I divide 1.75 by 10,000, I will end up with 0.000175 centimeters. And if we absolutely insisted, we could convert this to scientific notation, and it would be 1.75 multiplied by 10 to the power of negative 4 centimeters. Now that you have a method, I invite you to complete the following two conversions. I'll give you 5 seconds to do it. Okay, that wasn't 5 seconds, but I'm an impatient cauliflower. So let me examine the second conversion. We need to go from kilograms to micrograms. This time we are going from a bigger unit to a smaller unit. I am expecting the number to increase. The method is the same. I'm going to express the value given to me as a fraction first. Then I'm going to establish a blank conversion factor. After that, I'm going to write what my expected result is in terms of the unit. And now I'm going to use the expected unit of the result to guide the conversion factor. I want micrograms above the line in the result, therefore micrograms will be above the line in the conversion factor, and kilograms will be below the line. Kilogram represents a bigger unit, so I place a 1 next to it. This is a metric system, so I can already place a 1 for micrograms. I need the number of zeros. To figure that out, I'm going to look at the difference between the exponents of the scientific notation. Kilo is 1 times 10 to the power of 3. I'm interested in the 3. Micro is 1 times 10 to the power of negative 6. I'm interested in the negative 6. The difference between negative 6 and 3 is 9. Therefore, I will have 9 zeros. And now I can multiply my fractions. 7.8 times 10 to the power of negative 8 multiplied by a billion will give me 78. 1 multiplied by 1 will give me 1. Kilograms above the line will cancel kilograms below the line, which is great because I want micrograms. Finally, 78 micrograms divided by 1 is 78 micrograms. In the third conversion, we are going from liters to picoliters. We are going from a bigger unit to a small unit. Therefore, the number will increase. As before, I'm going to write the given value as a fraction and multiply it by a blank conversion factor. And when everything is said and done, I want my result to be in picoliters. As before, I'm going to use my result to guide the conversion factor. I want picoliters above the line in the result, therefore picoliters goes above the line in the conversion factor. This means that the other unit, liters, goes below the line. Liter is bigger, so I place a 1 next to it. This is a metric system, so I can already write a 1 for picoliters, but I need the number of zeros. Once again, I'm going to compare the exponents in the scientific notation. For pico, it is negative 12. For liters, well, that would be 0. Remember that our unit without the prefix is exactly in the middle of our unit scale. And the value there is 1, and in scientific notation that can be expressed as 1 times 10 to the power of 0. The difference between 0 and negative 12 is 12. Therefore I need, oh dear Lord, 12 zeros. Seriously, what was I thinking? How about I just write it in scientific notation? So a trillion, or 1 with 12 zeros, is also 1 times 10 to the power of 12. Now I can multiply my fractions. And that will give me 2.49 over 1. 2.49 divided by 1 is 2.49. Note that this is not the only way to perform unit conversions, but it is my favorite. Even though it may appear a little bit long-winded, the reason I like it is because I can use the expected result to help me construct the conversion factor. Besides, I get to use fractions, and a fraction is always a part of a story. That is all for now, and I will see you on the flip side.